6. So 2 to the power n is equals to 2 to the power 12. This implies that n is equals to 12. Now, what we have to find? Greatest coefficient. We know that for NCR, the greatest coefficient is when R is equals to n by 2 if n is even. So this is thing for greatest coefficient. Now putting R equals to 12 by 2, that will be 6. So our greatest coefficient will be 12C6. On solving it, we will be getting 12 factorial upon 6 factorial into 6 factorial. When you will solve it, you will get the answer C, that is 924. Clear? Moving to the next question. The positive integer just greater than 1 plus 0.0001 to the power 10000. So what we are having here is, we are having this value is reciprocal of this value. So it is in the form of 1 plus 1 upon x to the power x. Now if you remember, then in limits we have seen for limit x tending towards infinity, this value is equals to e. So when x is very large, then we can see that this value is nearly equals to e. So we can see 1 plus 0.0001 to the power, this will be nearly equals to e, and e is 2.73. So we can see that our answer is just greater than this S3. So you don't have to apply the basic expansion here. Moving to the next question. We are given r and n are the positive integers where r is greater than 1 and n is greater than 2, and the coefficient of r plus 2th term and the third term in the expansion of 1 plus x to the power 2n are equal. Then we need to find the value of n in terms of r. So let's find the coefficient of r plus 2th term. So r plus 2th term, we know that for 1 plus x to the power 2n, the general r plus 1th term will be 2ncr and x to the power 2n minus r. Or you can write as 2ncr x to the power r. You can write as x plus 1 to the power 2n. So r plus 2th term will be 2nc. Here is r plus 1, then r, then it will be r plus 1 or x to the power. See, we are interested only in the coefficients, so we are writing the coefficient of it. And the coefficient of 3rth term. So that will be 2nc. If we will equate these two, so 2ncr plus 1 is equals to 2nc 3r minus 1. So we know that if ncx is equals to ncy, then it implies that either x equals to y or x plus y is equals to 2n. So here x plus y equals to 2n, that is r plus 1 plus 3r minus 1 is equals to 2n. So this will be 4r equals to 2n. We need to find the value of n, so n will be equals to 2r. So the correct option is option number C. Moving to the next question of binomial. We are given if x is a positive, then the first negative term in the expansion of 1 plus x to the power 27 by 5s. See, if we are having the expansion of 1 plus x to the power n, so it is 1 plus nx plus n minus 1 upon 2 factorial into x square plus so on. So we can see that the general r plus 1th term will be n minus 1, n minus 2, n minus 3, and so on up to n minus r minus 1 upon r factorial into x to the power r. So here we are having n equals to 27 by 5. So it will be 27 by 5 into 27 by 5 minus 1 and so on. So we need the term for which this value 27 by 5 minus r minus 1 should be the first negative, that is less than 1. So that will be 25 by 7 minus r plus 1 less than 0. So r is greater than 32 by 5. So the r is greater than 7, that is r is equals to 7. So our term will be r plus 1th term, that is it will be 8th term. So our first negative term will be the 8th term. So our answer is option number 8. See, if you need to find the first negative term, then we have to write it in the general expansion, and we have written that the general term r plus 1th term will be equals to this. In this, the term first one is n minus 1, n minus 2, and so on. So we need that this quantity n minus r minus n minus in bracket r minus 1 should be negative, so that it will be a whole term will be negative, the first negative term will appear there. So we have put it and we have calculated the value of r, that is r is greater than 32 by 5, that is 6 point something. So that means r is equals to 7. So the term will be r plus 1th term, that is 8th term. Moving to the next question. Our next question is the coefficient of middle term in the binomial expansion in the powers of x. No, r is greater than 6. R cannot be equals to 6. In the previous question, r cannot be 6, because if we will put 6 in here, then this will be 27 by 5 minus 5. That will be a positive value. That won't be a negative value. And multiplying all the positive values, we are not going to get a negative value. So we need at least one negative, or we can say odd number of negatives. So the first negative term will appear when we will have the only one term negative. Now moving to the next question, the coefficient of the middle term in the binomial expansion of the powers of x of 1 minus alpha x to the power 4 and 1 minus alpha x to the power 6 is same if alpha equals to. we know that the middle term is, if we are having a plus b to the power n, then the concept of middle term is, if n is even, then we are having t n by 2 plus 1th term as the even middle term, and if n is odd, then we will be having two middle terms, that is tn plus 1 by 2th term and tn plus 3 by 2th term. Here, both the cases n is even, so the first case, the middle term will be t 4 by 2, that will be 2 plus 1, so that will be 4c2, and minus alpha x to the power 2, so that will be 4c2 alpha square x square. For the next one, the middle term will be 6 by 2, that is 3 plus 1 at term, so that will be 6c3 minus alpha x to the power 3. So that fourth term will be 6c3 with minus sign alpha cube into x cube. We are given that the coefficients are equal, so equating the two coefficients, we will get 4c2 alpha square equals to minus 6c3 alpha cube. We know that value of 4c2 is 6, alpha square equals to minus 6c3, it will be 20 alpha cube. So alpha will be equals to minus 6 by 20, that is minus 3 by 10. So the correct option is option number C. Now moving to the next question. We are given, if the coefficients of rth, r plus 1th and r plus 2th term in the binomial expansion of 1 plus y to the power m are in AP, then m and r satisfies the equation. So the coefficient of rth term will be mcr minus 1, r plus 1th term, the coefficient will be mcr, and r plus 2th term, the coefficient will be mcr plus 1. It is given that these coefficients are in AP, that is 2 times the middle term is equals to first term plus last term. So that is 2 into m factorial upon m minus r factorial into r factorial equals to m factorial upon m minus r plus 1 factorial into r minus 1 factorial plus m factorial upon, oh sorry, this m minus r minus 1 factorial into r plus 1 factorial. So m factorial will get cancelled out. We will be having 2 upon, see the least value of factorial is m minus r minus 1. So we can write this m minus r factorial as m minus r into m minus r minus 1 factorial, and here it is r minus 1 factorial, so r factorial can be written as r into r minus 1 factorial. It is equals to 1 upon m minus r plus 1 into m minus r into m minus r minus 1 factorial into r minus 1 factorial plus 1 upon m minus r minus 1 factorial into r plus 1 into r minus 1 factorial. So cancelling the common terms, and solving, we will get this value as 2 upon m minus r into r equals to 1 upon m minus r plus 1 into m minus r plus 1 upon r plus 1 into r. So what we were having 2 upon, so let's take the LCM part. Okay, on solving this, taking the LCM and simplifying, you will get your answer. Okay, so that will be 2 into solve it here. And this is the other method by which you can solve it. So if you want to solve it, then it is 2 MCR equals to MCR minus 1 plus MCR plus 1. So keep this in denominator, you will be having, and we know that this ratio is equals to MCR minus 1 upon MCR is equals to R upon M minus R plus 1. And MCR upon MCR plus 1, it will be equals to, okay, it was R plus 1 upon MCR. Oh no, yeah. So this value will be M minus R upon R plus 1. On simplifying, we will get the option number C. Going to the next question. Our next question is, we are given if the coefficient of x to the power 7 in the expansion of ax square plus 1 upon bx to the power 11 equals the coefficient of x to the power minus 7 in the expansion of ax square plus 1 upon bx to the power 11, then a and b must satisfy the relation. So we have to find the general term of this. So r plus 1 term will be 11cr ax square to the power 11 minus r and 1 upon bx to the power r. That will be 11cr into a to the power 11 minus r x to the power 22 minus 2r into b to the power minus r and x to the power minus r. So that will be equals to 22 minus 3r. And we have to find the coefficient of x to the power 7th term. This implies that 22 minus 3r should be equals to 7. So 22 minus 7 equals to 3r. So r is equals to 5. Now the general term for this expansion will be 11cr ax square to the power 11 minus r, same it will be 1 upon bx to the power r. So it will be 11cr a to the power 11 minus r x to the power 22 minus 3r into b to the power minus r. We have to find the coefficient of x to the power minus 7. So that will be 22 minus 3r equals to minus of 7. Oh no, sorry. Actually, we are having a printing mistake in here. It is ax and 1 upon bx square. So this is term and the other term is this. So you would be having x to the power 11 minus r b to the power r and minus 1 to the power r and x to the power minus 2r. So that will be 11 minus 3r equals to minus 7. So 3r will be equals to 18. So r is equals to 6. So the coefficient we are getting in here was 11c5 a to the power 6 b to the power minus 5. And here the coefficient we are getting are minus 1 to the power 6 will be even. So that is 1, and the coefficient will be 11c6, a to the power 5, b to the power minus 6. These two are equal. So equating this, 11c5 and 11c5s are same, so that will be cancelled out. You will be getting a to the power 6 upon b to the power 5 is equals to a to the power 5 upon b to the power 6. On simplifying, you will get a into b equals to 1. So the correct option is option D. Now, moving to the next question. So the next question is, in the expansion in the powers of x of the function 1 upon 1 minus ax into 1 minus bx is this, then an is equals to. So you can see that it will be 1 minus ax to the power minus 1 into 1 minus bx to the power minus 1. So remember, 1 minus m to the power minus 1 is 1 plus m plus m square plus m cube plus so on up to infinity. This you can get from the formula of infinite GP. It is an infinite GP with common ratio m and first term 1. So it will be a upon a minus r. So that is 1 minus m to the power minus 1. So 1 minus m to the power minus 1 can be written like this. So 1 minus ax to the power minus 1 will be 1 plus ax plus a square x square plus a cube x cube plus so on up to infinity into 1 plus bx plus b square x square plus b cube x cube plus so on. Now we have to find the coefficient of nth term, an. So here, if we are writing it as a naught plus a1x plus a2x square a3x cube, then it will be a n x to the power n. So we need to find the coefficient of x to the power n. So we can write it till, let's say we are having some a to the power n x to the power n, and still it is going on. And here also it is b to the power n x to the power n, and still the series is going on. So how we are going to get? We have to multiply this one with this coefficient, then we will get x to the power n. Then ax we have to multiply with the term preceding it. So we will be having b to the power n plus a into b to the power n minus 1 plus a square into b to the power n minus 2 plus a cube into b to the power n minus 3, and so on up to a n minus 1 b plus a to the power n into 1 into x to the power n, and we will be having more terms, but this will be the coefficient of x to the power n. So which option is matching? Now if we'll see, then directly no option is matching with this term. But we know that if you are having, see, this is a generalized thing. If you are having x square, or we can say if you are having a square minus b square upon a minus b, then it will be a plus b. If you are having a cube minus b cube upon a minus b, then it will be a square plus ab plus b square. Similarly, if you are having a to the power 4 minus b to the power 4 upon a minus b, then it will be a cube plus a square b plus a b square plus b cube. So you can generalize that with, if you are having a to the power n plus 1 minus b to the power n plus 1 upon a minus b, then it is equals to a to the power n plus a to the power n minus 1 into b plus a to the power n minus 2 b square, and so on up to b to the power n. So this coefficient matches with the option, oh, sorry, matches with the option D because B is like this. Okay, we are having B and B in the denominator. If you are having A, then you will be having A here. Okay, so this is something important. Now moving to the next question. We are given for natural numbers m and n, if 1 minus y to the power m and 1 plus y to the power n, it is equals to 1 plus a1y plus a2y square and so on, and a1 and a2 are given. Then we have to find the ordered pair m comma n. So 1 minus y to the power m will be 1 minus my plus mc2y square plus so on, and 1 plus y to the power n, it will be 1 plus ny plus nc2y square plus so on. If we are multiplying 1 minus y to the power m with 1 plus y to the power m, then we are having 1 minus my plus mc2y square and 1 plus ny plus nc2y square and the other terms. What we are interested in is a1, that is coefficient of y. So y we will get if we will multiply minus my with 1 or we will multiply plus ny with 1. So this is y n minus m plus y square if we will get when we will multiply it with 1. So mc2 plus if we will multiply nc2y square with 1 plus if we will multiply ncy ny and my, then it will be minus of m into n, and you will be getting y square and you will be getting many other terms. But we are concerned here with the coefficient of y and coefficient of y square because the values of coefficient of y and coefficient of y square are given. So the coefficient of y is n minus m, so n minus m equals to 10. And secondly, mc2 plus nc2 minus mn, so mc2 will be m into m minus 1 upon 2 plus n minus 1 upon 2 minus mn, it is also equals to 10. So on solving you will be getting m square plus n square minus 2mn minus m minus n by 2 equals to 10. So this will be m minus n whole square minus sign common m plus n equals to 20, and m minus n we are having 10 square, it will be 100. So we are having 100 minus 20 equals to m plus n, so m plus n is equals to 80. So from these two equations we can see that the value of, if we add these two, then n will be equals to 45, and putting the value of n 45, m we will get 35. So our option is option number D. The ordered pair is 35, 45. Now moving to the next question. The sum of the series 20C1 minus 20C0 minus 20C1 plus 20C2 minus 20C3 and so on up to 20C10 is, see, we know that if we are having 1 plus x to the power n, or we can write it 20, then its expansion will be 20C0 plus 20C1x plus 20C2x square plus 20C3x cube plus so on up to 20C20 x to the power 20. If we will put x equals to minus 1, why we are putting x equals to minus 1 is because we are having negative sign for all the coefficients whose power of x is odd. So putting x equals to minus 1, 0 will be equals to 20C0 minus 20C1 plus 20C2 minus 20C3 and so on up to 20C20. The term preceding it will be 20 minus of 20C90. So we know that the coefficient, if for combinations we are having the formula NCR is equals to NC n minus R. So 20C0 and 20C20, these are having the same value 20C20, so it will be 2 times of 20C20. Similarly 20C1 and 20C19 will be 2 times of 20C1 and so on. We can go up to 2 times of 20C9, but 20C10 will be only once. So that's why we need to add and subtract 20C10, or we can say adding 20C10 both the sides since it was equals to 0. So now 2 we can take out common, so we will be having 20C0 minus 20C1 plus 20C2 and so on up to 20C10 equals to 20C10, and this 2 in multiplication, if we'll take it into the RHS then it will be in divide, so our answer will be 1 by 2 20C10, which is our option number B. So the correct option is option number B. Moving to the next question. We are given to find the coefficient of x to the power minus 7 in the expansion of this term. So first we have to simplify it and we'll write it as 1 minus x we have taken common, and from these two we can take x square common, so it will be 1 minus x again. So it is 1 minus x into 1 minus x square to the power 6. 1 minus x we can write it in the form 1 minus x into 1 plus x. So it will be 1 minus x square into 1 plus x to the power 6. So we are having 1 minus x square to the power 6 into 1 plus x to the power 6. Now 1 minus x square will be, or you can open it by binomial, it will be 1 minus 6c1x square plus 6c2x to the power 4 plus or minus 6c3x to the power 6. The next term will be plus 6c4 x to the power 8, but we are not interested in it because we have to go maximum up to 7, so we are not writing that term. And 1 plus x to the power 6 will be 1 plus 6c1x plus 6c2x square and so on up to 6c6x to the power 6. Now we are interested in finding the coefficient of x to the power 7. So 7 we can get when 1 we are not having 7 here. With 2 we are having 5 in here. So that will be minus 61 into 65 plus with 4 we are having 3 in here. So plus 62 into 6c3 with x to the power 6 we are having x in here. So minus 6c3 into 6c1. So on solving this, we will be getting 6 into 6, 62. Put all the values and you will get the answer minus 144. So the correct option is A. Now let's start with some multiple choice questions. So our first question is the values or values of x. Yeah, that was right. I did a mistake in there. Okay. The values or values of x in the expansion of x plus x to the power log x to the base 10 to the power 5 if the third term of the expansion is this. So now the third term is given, so we can find the third term. So tr plus 1 term, that is 2 plus 1 term will be the third term. So it will be 5c2 x to the power 5 minus 2 into x log x to the power log x to the base 10 to the power 2. And this value is given to be 10 to the power 6. 5c2 we can calculate. X to the power 3 plus 2 log x to the base 10. And 5c2 will be 5 into 4 into 3 factorial. So this will be cancelled out. This will be 10. So on cancelling, we will be getting 10 to the power 5. Taking log to the base 10 both sides. So log x to the power 3 plus 2 log x to the base 10 to the base 10 is equals to log 10 to the power 5 to the base 10. So we will be writing log x to the base 10 equals to t or something. So we will be having 3 plus 2t into t, because the power will come in front in multiplication, it is equals to 5. So our quadratic equation will be 2t square plus 3t minus 5 equals to 0. On solving it, we will be getting t equals to 1, matlab t minus 1 is one factor, and 2t plus 5 equals to 0. So t will be equals to 1 or t will be equals to minus 5 by 2. T is log x to the base 10. So log x to the base 10 equals to 1. So x will be equals to 10. So our option number A is correct. And log x to the base 10 equals to minus 5 by 2. So x will be equals to 10 to the power minus 5 by 2. So our option number C is correct. So our correct options are A and C. Now we are given if the coefficient of rth, r plus 1th and r plus 2th term in the expansion of 1 plus x to the power 14 are in AP, then the value of r is. We have done the similar question. Okay, that was given in the power of m, and on simplifying we were getting a very big equation. So here the same concept we are applying. So r at term, r plus 1 at term, so it will be 2 ncr equals to ncr minus 1 plus ncr plus 1, and we are given already 14, so that will be 2 into 14cr equals to 14cr minus 1 plus 14cr plus 1. So on simplification, we will be getting 14 factorial upon 14 minus r factorial into r factorial equals to 14 factorial upon 15 minus r factorial into r minus 1 factorial plus 14 factorial upon 13 minus r factorial into r plus 1 factorial. So r factorial will be r into r minus 1 factorial. Here let r minus 1, 14 minus r into 13 minus r factorial. This will be 15 minus r into 14 minus r into 13 minus r factorial, and this will be r plus 1 into r minus 1 factorial. So from denominators we can cancel out 13 minus r factorial and r minus 1 factorial. So we will be left with 2 upon r into 14 minus r equals to 1 upon 15 minus r into 14 minus r plus 1 upon r into r plus 1. So on simplifying it, you will get a quadratic equation r square minus 14r plus 45 equals to 0. So this is 9 into 5. So r square minus 9r minus 5r plus 45 equals to 0. So that will be r minus 9 into r minus 5 equals to 0. So the value of r is 9 and 5. So the two correct options are A and D. Now moving to the next question. In the expansion of x plus a to the power n, if the sum of the odd terms in P is P and the sum of the even terms is Q, then see, we can do these questions with an objective approach. If you will put n equals to 1, you will be getting, or n equals to 2, you will be getting a better view. So it will be x square plus 2ax plus a square. So the sum of the odd terms, first term and third term, so p is equals to x square plus a square and q is equals to 2ax. On subtracting p minus q, what we are having? X square plus a square minus 2x. So that is x minus a whole square. Okay, but is this satisfying our condition? Yeah. So p minus q is x minus a whole square and p plus q is our expansion this x plus a whole square. So doing p plus q into p minus q, we are getting x square minus a square whole square. So this is satisfying our condition number A. Even you can put the values of a and x. Now secondly, 4 times of pq. So we are having p and q and x plus a to the power 2n. We know that x plus a to the power 2n matlab x plus a to the power 4 minus x minus a to the power 4. What it will be? It will be x plus a square minus x minus a square into x plus a square plus x minus a square. And this is our p plus q, x plus a square, and x minus a square is p minus q. So this is p plus q minus p minus q, and x plus a square is again p plus q plus p minus q. So what we are having here is 2 times of q, and what we are having here is 2 times of p, so it is 4 times of pq. So our option number B is also correct. Now going for the option number C, we were having 2 times of p square plus q square. So p square will be x square plus a square whole square and q square will be 4 times of a square x square. On adding these two, you would be getting x to the power 4 plus a to the power 4 plus 2 x square a square. So it will be 6 times. Now, on adding these two, we will be getting x square because n was equals to 2. Okay, now this is something, n was equals to 2, so you have to expand it to the power 4. So x plus a to the power 4 plus x minus a to the power 4. So that will be 4c0. That is the power containing a in odd terms will get cancelled out and we will be getting a in the even terms only. So that will be 2 times of x to the power 4 plus 2 times of 4c2 x square a square plus a to the power 4, and which is similar as this term because 4c2 is 6. So if we are taking 2 common, then we are getting p square plus q square. So our option number C is also correct. See, this is the way in which you can do it. And you can even put n equals to 1 and satisfy the conditions. But in most of the cases, n equals to 1 always satisfies the condition. So we have to take either 1 or 2 values. Or we can go it like solving it by the full method, that is writing x plus a to the power n, we have written the full expansion. Then the even terms and odd terms are odd terms, first term, third term, and so on. And the even terms are second term, fourth term, so on. We are having nc0 x to the power n plus nc2 x to the power n minus 2 a to the power 2. So on, this will be equals to p, and this all terms are equals to q. Now, if you are having p minus q, then odd terms will be in with minus sign. We know that if the power of a are an odd and it is having the negative sign, that it is x minus a to the power n. Multiplying these two terms, we will be having x square minus a square to the power n equals to p plus q into p minus q. So that will be p square minus q square. So this is one option. Now, if we will be squaring the first term and squaring the second term, then it will be x plus a to the power 2n will be equals to p square plus q square plus 2pq. And on squaring the second term, it will be x minus a to the power 2n equals to p square plus q square minus 2pq. On subtracting, we will be getting 4pq here, so that will give us the other option. Similarly, on squaring the first and squaring the second and adding these two, we will be getting the third option. Okay. Moving to the next question. Our next question is, we are having if 4 plus root 15 to the power n is equals to I plus f, where n is an odd natural number, I is an integer, and f belongs to 0 to 1, that is f is a fractional part. Then we need to find whether I is an odd integer or I is an even integer. See, these types of questions you will have if we are having 4 plus root 15, then 4 minus root 15 will be a number lying between 0 to 1. Okay, so 4 minus root 15 to the power n will also lie between 0 to 1. Why we are doing here is because we have to deal with the integer values, and we know that we have to remove the terms containing 15 to the power for root 15 to some odd powers. So what we are doing here is, if we will add the expansion of 4 plus root 15 to the power n plus 4 minus root 15 to the power n, then we will get only the terms containing even power of root 15. Let's name this term f dash. So we are having I plus f dash, where f dash we have defined 4 minus root 15. So we are having all the integral values here, that is nc0 4 to the power n plus nc1 4 to the power n minus 1 root 15 plus nc2 4 to the power n minus 2 root 15 square, and so on, plus 4 nc0 4 to the power n minus nc1 4 to the power n minus 1 root 15 plus nc2 4 to the power n minus 2 root 15 square, and so on. So if we'll see, then the odd powers of root 15 will cancel out, and root 15 square or root 15 even powers will be an integral values. So these integral values are getting added two times, so it is 2 into some integer. So this all value is an even number. Now here see, f lies between 0 to 1. F dash is also lying between 0 to 1. So f plus f dash should lie between 0 to 2. So the maximum value it can have, maximum integral value it can have is 1. And since I plus f dash is some even number, that is it is an integer value. So this implies f plus f dash should be equals to 1, and this implies I plus 1 is giving me an even number, so I should be an odd number. So our option number A is correct. Secondly, I plus f dash equals to 1, and if we will multiply these two terms, then 4 minus root 15 into 4 plus root 15, it will be equals to 16 minus 15, so 1. If we are having power n, then also it will be equals to power 1 to the power n, that is 1. So we can say I plus f into f dash is equals to 1, and we are having the value of f dash equals to f plus f dash is equals to 1. This implies f dash is equals to 1 minus f. So I plus f into 1 minus f is equals to 1. So option C is correct. Option B is not correct. And f dash we have taken it to be equals to 4 minus root 15 to the power n. So it is equals to 1 minus f. So option number D is correct. In the similar type of questions, sometimes we get the terms in the form of root a minus b to the power n. In this case, if you are getting in this term, then you have to multiply and or take f dash as root a plus b. And now moving to the next question, we are having f of m is equals to summation I equals to 0 to m 30. See, this is a form in which we write NCR. So Fm we can write it as, we are having Fm equals to summation I equals to 0 to m 30c 30 minus I into 20c m minus I. And we are putting the values of I from 0 to m. If you look at it, then it will be 30c 30 into 20cm plus 30c 29 into, oh, sorry, 30c, yeah, 29 into m minus 1, and so on. So what these terms represents us, if we are having 1 plus x to the power n, then the coefficient of x to the power n is NCR, or we can say the general term is NCR x to the power r. So here, if we are having 1 plus x to the power 30, then the general term will be 30CR and x to the power r. And if we are having 1 plus x to the power 20, then the general term will be 20CR1, let's say, into x to the power r1. Multiplying these two coefficients and r plus r1, if you will add these two, so this, so this will give us the coefficient of, write it like 1 plus x to the power 30 into 1 plus x to the power 20. In this we will get, or we can say that in the expansion of 1 plus x to the power 50, we are getting the coefficient of expansion of x to the power m in here, because from these two terms we are getting m. See, the general term will be 30c or we can write the expansion like 1 plus 30c1x plus 30c2 x square plus so on up to 30c 30 x to the power 30, and in this 1 plus 20c1x plus 20c2 x square plus so on up to 20c20 x to the power 20. If you are having this value I equals to 0 to m, so that will be 30cm in the end. Okay, so if we are having some term, let's say in middle we are having 30cm x to the power m, and here we are having 20cm x to the power m. So if you will multiply 1 with this, you will get the coefficient of m. So that will be 30c0 x 20cm. When we will take 1 in here, you will have taking 20cm minus 1 here. So that will also give you x to the power m. Similarly, 30c2, and here you will be getting 20c18, okay, and x to the power m minus 2. So again you will be getting x to the power m. So this term is representing the coefficient of x to the power m in the expansion of 1 plus x to the power 30 into 1 plus x to the power 20. So this value will be equals to 50 cm, because if you are taking 1 plus x to the power 50, then the coefficient of x to the power m will be 50 cm. So we can directly write that Fm is equals to 50 cm. Now, moving to the options, the maximum value of Fm is, so we will get the maximum value of Fm when m will be equals to half of that value, nc2, n by 2. So m will be equals to n by 2, that will be 25. So our option number A is correct. Next, this is f of 0. So f of 0 plus f of 1, so on up to f of 50. So we are having f of m equals to 50 cm. So f of 0 plus f of 1 plus so on up to f of 50 will be again equals to the sum of coefficients. So that will be 50c0 plus 50c1 plus so on up to 50c50. So this quantity will be equal to 2 to the power 50. So our option number B is correct. Now, we are given f of m is divisible by 50. So f of m is 50 factorial upon 50 minus, okay, so we are having this as 50 cm. So it won't be divisible by 50 for m lying between 1 to 49. Not always divisible, because you will get some terms which will won't be divisible. Okay, like 49 only you can put, not 49, the other terms you can put. And then for the option number D, the value of m equals to 0 to summation 50, f of m square equals to this. So we are having mc0 square plus mc1 square plus so on up to m 50c0 square plus 50c1 square so on up to 50c50 square. So we know that this comes out to be the coefficient from 1 plus x to the power 2n, when we'll write it as, or solve it as, this value is 100c50. How you can solve it is, you can write 1 plus x to the power n. So it will be nc0 plus nc1x plus nc2x square plus so on up to ncn x to the power n. Similarly, you can write it in the backward. So you can write it like x plus 1 to the power n. So it will be nc0 x to the power n plus nc1 x to the power n minus 1 plus nc2 x to the power n minus 2 and so on up to ncn. If you will multiply these two terms, then in LHS it will be 1 plus x to the power 2n, and in RHS you will be having multiple number of terms, but the coefficient of x to the power n will be nc0 into nc0, that will be nc0 square. Coefficient of x to the power from here will be nc1 square, and so on up to ncn whole square, x to the power n, and many other terms. So the coefficient of x to the power n here is c naught square plus c1 square plus c2 cn square, and here it will be 2n cn. So that will be 100 c50. Okay, that's it for today. Thank you.